Okay, so before I set you free on the worksheet, just one more example of a ionic compound where the charges have to balance out, just to be really clear here. Okay, so if we look at this image, see if we can pull it up. Here's a great image. Okay, just a random image. We have aluminum and we have fluorine, right? And they form a compound called aluminum fluoride, which is AlF3. So the question is, why are there 3 fluorines here that have to attach, form an ion, and then bond to aluminum? And the answer is that it has to do with their charges, just like we were talking about. So aluminum actually forms a 3 plus cation. And we'll notice that if we look at our worksheet, that's what we see here. So Al3 plus. And then fluorine forms a 1 minus charge. And we know that because it's a halogen in group 17. It had 7 valence electrons. It only gains 1. So from your drawings last week, you notice that if fluorine only needs 1 additional valence electron, but aluminum needs to get rid of 3 electrons to form that 3 plus charge, then we're going to have to add 3 fluorines or fluorides, once it becomes an ion, to aluminum in order to form a balanced compound. And so we're going to notice we have 1 minus here, Al3 plus. So last week we were drawing these 1 minus fluorine, 1 minus. So this week, what we're going to do, we don't actually have to draw this out every time. But what we want to do is make sure that our charges all balance out. And so what we can do is just add up the positive and negative charges. So here we have 1, 2, 3 negative charges and 3 positive charges. So we're going to go 3 positive. So 3 plus, and we're going to add up our 3 negatives, right? And 3 negatives. And again, this is not the right way to write like a math equation, but I think it's the easiest way to just show, okay, if I want to put this in parentheses, that's fine to just show. So 3 plus negative 3, right? If we were in math, I would write that negative sign on that side, not that side. But when we write out our charges on compounds, we write the charge on the right-hand side. So I just keep it consistent like that. So if we add these together, of course, we get a total of 0, which tells us this is balanced out. Now, there's another way that I can do this, which is actually really easy as well. So let's erase all of this. And so the easy way to do this, and there's a little trick here, is to just take the charges that you see on each element or each ion, and we're going to flip-flop them. So we have Al3 plus and fluorine 1 minus. Now we ignore the charge itself. We know that's what attracts them, right? Because opposites attract. So in my compound, I'm going to actually end up with 1 aluminum here. Now in chemistry, if something only has 1, we don't have to write the 1, but I could write the 1 here just to show that. If I write it at all, that means, that's obvious that there's only 1 there. And then for fluorine, we're actually going to have 3. So that 3 goes down here. So look at, now all of a sudden, so let's eliminate the 1. I'm going to rewrite it again without the 1 because it's not necessary. So AlF3, and that is the final answer and what we get. So there's some little tricks for how to write these ionic compounds, but today, so just know that those charges have to balance out, right? So if I have 3 negative 1 charges, they cancel out the 3 plus charge on aluminum. That's what we want. That's how we have a good ionic compound. Next up, we need to name it, which is what your worksheet's all about.